Okay, so the AI boom, it's everywhere, right? It's powering just about everything, from the chatbots we talk to some really incredible scientific discoveries. But here's the thing, this whole digital revolution has a massive, and I mean massive, physical footprint. See, AI needs data centers, and data centers need a truly astronomical amount of power and land. And that demand, it's starting to cause some very real friction right here on planet Earth. So much so that it's pushing us to look for a solution in a very, very different place. Space. Let's get into it.
And this is where things get tense. That's a quote from a local official in rural Kentucky, Mason Barnes. He's talking about the skepticism folks have when developers show up promising jobs and revenue in exchange for building these enormous, power-guzzling data centers. Communities are starting to push back. They're worried about transparency, they're worried about their energy bills skyrocketing, and they're worried about the environmental impact. And the scale here, it's just staggering. 1.3 gigawatts. That's how much new power generation Kentucky's biggest utility says it needs to build. And most of that is to support the expected demand from these new AI data centers. To put that in perspective, that's enough juice to power over 1 million homes. So yeah, this massive, massive need for power on Earth is exactly what makes the idea of moving the whole operation off-world so appealing.
So with all these problems piling up down here, you gotta ask the question, why not just move it all to space? I mean, think about it. You've got limitless solar power, and there's no single government in charge. On the surface, it really does seem like the perfect, elegant solution.
And look, this isn't just some sci-fi dream. This is happening, right now. Companies are already building this stuff. Axiom Space, for example, has been running cloud computing on the International Space Station since 2022. And get this, they're planning to have a network of at least 3 orbital data centers up and running by 2027. The future is definitely arriving a lot faster than we think. Okay, but here's the twist. This is where what we think we know about space gets turned completely upside down. We all think of space as cold, so cooling down a hot computer should be a piece of cake, right? Well, the actual physics of it tells a very different and much hotter story. Let's just tackle this head on. I mean, we've all heard the phrase, the cold vacuum of space. It's a super common misconception that because space is a vacuum and it's incredibly cold, anything you put out there will just naturally stay cool. But that's just not how heat actually works.
You see, down here on Earth, we get rid of heat in a few ways. There's conduction, which is heat moving through direct touch, and then there's convection, which is heat being carried away by a flow of air or water. That fan inside your computer, that's convection in action. But in the vacuum of space, you don't have air, you don't have water, so you're left with just one option, radiation.
And this right here is maybe the best way to think about it, and it actually comes from a Reddit user, which is awesome. A thermos uses a vacuum to insulate your coffee and keep it hot for hours. Well, space works the exact same way. It's the ultimate insulator, and it is incredibly good at trapping heat in.
So here's the bottom line. Without air to blow across heat sinks or water to pump through cooling pipes, a data center in orbit would be trapped with all its own waste heat. It would just build up and up and up until the electronics would literally cook themselves from the inside out. That cold vacuum of space is actually a terrible place to try and cool something down.
All right, so space is a giant thermos. That's a huge problem. But, this is where the engineers get to shine. This is where human ingenuity comes in. When the old methods don't work, you've got to invent completely new ones.
And yeah, that is exactly what's happening. What you're looking at here is an experiment at Sandia National Laboratories. Scientists there are developing a totally radical new way to pull heat off of high-power electronics. And it's designed specifically for places like space, where traditional cooling just isn't an option.
It's called jumping droplet cooling. And it sounds wild, but here's the gist. First, tiny water droplets form on this special surface that really hates water. When 2 droplets merge together, they release a tiny bit of energy that makes them literally jump off the surface. Then an electric field acts kind of like a tractor beam, pulling those jumping droplets directly onto the hot computer chip. They hit the chip, instantly evaporate, and carry all that nasty heat away with them. Pretty cool, right? And the results are just incredible. This method was shown to improve heat transfer by about 200% compared to trying to cool without the jumping effect. That's not a small improvement. That's a potential game changer.
And this isn't even its final form. The researchers who developed this think that with a little more work, this tech could dissipate up to 1 kilowatt per square centimeter.
That is an absolutely immense amount of cooling power, and it might just be the breakthrough needed to make orbital data centers a reality.
Okay, so let's imagine for a second we crack the physics problem. We solve the cooling, we've got limitless power, we're still left with this massive, massive question. Who makes the rules up there?
You have to go all the way back to 1967. That's when the main law of space, the Outer Space Treaty, was signed. Back then, only a handful of governments could even get into orbit. But now, we have private companies building commercial infrastructure in space. The legal rulebook is just decades and decades behind the technology.
So, the treaty says that space is not subject to national appropriation. But what does that actually mean today, in an age of commercialization? Can a private company go mine an asteroid and sell what they find? Can they set up a data center and claim an exclusive safety zone around it? The language in the treaty is just too ambiguous, and it is totally unequipped for the challenges we're facing right now.
So what's the fix? You can't just throw out the whole treaty, right? That would be a mess. Well, one really interesting proposal is to create a Conference of the Parties, or a COP, for the Outer Space Treaty. It would basically be a regular meeting where all the nations could get together and agree on how to interpret the original text for modern issues, like data centers or asteroid mining. It's a way of updating the rules without having to start from scratch.
Okay, let's zoom out and put all the pieces together. We've talked about the physics, the engineering, the international law, but the to-do list for making data centers in space a real workable thing is, well, it's still immense.
So here it is, the big checklist. First, you have to solve that fundamental physics problem of cooling in a thermos. You need to generate and store huge amounts of reliable solar power. You have to figure out data latency, that speed of light delay for signals to get to space and back, because any delay over about 120 milliseconds is actually noticeable to us here on Earth. You have to figure out how on Earth you're going to do maintenance and repairs. And of course, you need to nail down a clear legal framework so everybody knows the rules of the road. At the end of the day, this dream of moving our digital world into orbit is an incredibly powerful and compelling idea. It really could solve some major problems down here and kickstart a whole new era of computing. But as we've seen, the gap between that dream and the reality, it's filled with some mind-bending challenges, from basic physics all the way to international law. So the real question isn't just, can we do it? It's, are we truly prepared for everything that comes with it?